Boy, this whole system is so screwed up right now. Okay, I don't know why it has me in their announcements. So I think I'm going to close this. Um, and let me go back to, I'm going to have to log in the Blackboard again. Blackboard is just a pain in the neck. Okay, now there's two announcements here. I'm going back to here and log in the Blackboard here. Okay, now let's see. I'm going to have to, I can't tell what it's doing now. Okay. Okay. Now, I have moved this so many times. Okay. Why is it only showing one screen here? Ah, here we go. Maybe I could have done that before. Okay. Finally, we're getting close. Okay. Here we are finally in our course again. So I'm going to take y'all and move you up here. You can't tell, but I did that. And let's go to weekly assignments and activities. Okay, I'm going to open that. I'm going to try to open that. And I think we're now in week 4. Is that not correct? Okay. Now, is this some more people coming in? Nope, I don't see anyone new here. Okay. All right. Here's week 4. Here is lab 6. I'm going to click on this, and they did not allow me a way to put the lab here. But if you want to submit your lab, you can use this space if you want to. You don't have to. You can use Blackboard message. You can do an email, however you want to do. So I'm going up to instructional materials. Again, we're in lab or week 4 here. Okay, week 4, instructional materials. Click on that. And I can't tell if this is someone coming back into the class or not. I don't see anybody. So here the PowerPoint shows we finished PowerPoint 3. We started PowerPoint 4 today. And then all the other things here. Here's our good old web link that's going to take us to PHET. So you can go right there if you want to. And I'm going to click on it, and now I had it open before. I'm going to have to move things around. Okay, so let me get up my Word document here. All right, no, sorry that this is small. It decided to do this. Go to the Blackboard page for this course. Go to course content. Go to week 4 instructional materials. That's where I just went. Scroll down to the laboratory simulation that was on that same screen. Click on simulations and then on physics. So here we are doing that. I'm going to click on simulations, then physics. Scroll down to energy forms and changes. Click on download. Actually, you don't have to do that. You can hit this triangle in the circle. It goes straight there. When it is downloaded, click on it. It will open on and click on system. So I hope you're getting all this down. Turn on the energy symbols, and when you see mechanical, think gravitational potential energy or kinetic energy. They're using mechanical for either one of those. Okay, so that's where we're heading. So I'm going to leave this open. Oh, I'm sorry, you can't see that, can you? Okay, sorry about that. Here's the verbiage. You can see that now. Y'all say something when you can't see it. I just noticed they had turned off the connection there. Okay, so we're going to do what they say here. Go to Blackboard page in the course. I've already done that. Course content, already done that. Go to week 4, instruction materials, already done that. Scroll down to laboratory simulations. We've already done that. Clicked on simulations. Now we haven't done that. So we're going to pick up from there and go. So our new share here is going to be this one, I think. Yeah, there we are. Now we're on the PHET interactive simulations. Go to simulations, go to physics. Click on that. All right. And where we're going today is scroll down here until we get to energy. Can anyone remember how it was titled? Was it energy forms and changes? Okay, that's it right there. Okay. And then you don't have to do the download. All you have to do is click on this triangle and the circle. You don't have to do this download here. Triangle and the circle. Click on that, and now it's starting up. Now, some of them take longer to load than others. Let's see how this does. Okay, we're going to do, I think we go to intro, don't we? Or do we go systems? I've forgotten now. Let's go back and see. On systems, okay. Okay, so okay, wait, let me get back to that. Okay, click on systems. That's where I thought it was, but let's see. Here we go. All right. Happy little bicyclist here. So we're going to click on energy symbols here. Got it? Now you see, when they say mechanical, you think either potential or kinetic. Okay, that's what I was saying there. Then we'll have an electrical energy, that's the blue. Thermal is red. Light is yellow, and chemical is green. Okay, so this mechanical, you think either potential or kinetic, one or the other. Okay, what does it say to do next? When you see the mechanical, think of either the gravitational, potential energy, or kinetic energy. Right. That, okay, so that's the grayish one here. Electrical is electrical, thermal is red. Electrical's blue, thermal's red, light is yellow, and chemical is green. Okay, now we have the bicyclist here. What does it say do next? Click on the blue pool on the faucet repeatedly. Okay, you see the faucet here? So we're going to start with that, so I'm going to click on that. Okay, now what I'm going to do, I'm going to start pumping on this faucet. So what's going to happen, water is going to come out here. What kind of energy is that water going to have? Okay, it is a liquid, but what kind of energy does it have? Mechanical, electrical, thermal, light, or chemical? Mechanical. What kind of mechanical? Remember, there's two different ones it could have. It's going to start at gravitational potential because it's up here. But as it starts falling, then it's going to have kinetic. Perfect. Okay. And then we'll follow what happens from there. Okay. So are you ready for me to start pumping on the tube here? Okay. What's your first question going to say? Okay, and I think you've already answered that. What was that form? Mechanical. Okay, it says what form of mechanical? No, it's going to start with potential and then rapidly go to kinetic. So here, watch and see what happens. I'm going to start pumping on this, and there you see the energy. It starts as potential and then it makes kinetic as it turns the water wheel. Now what happens then? What does the next statement say?
Into what form does it change as it falls?
Okay, yeah, it started off as potential, went to kinetic as it falls, and then some of that kinetic change. Okay, what's the next question?
What form does it give the paddle wheel?
Okay, that's again kinetic because the wheel is turning. Okay, what's the next question?
Is all the energy of the water converted to the energy of the paddle wheel?
No, you see some of it falls on down here. You see that one went right on past. Okay, did you see that? See, some of it goes to the paddle wheel, some of it falls down. You see those?
Ah, okay, yes.
Okay. Now, what's the next question?
The paddle wheel is excuse me, I'm sorry. The paddle wheel is connected to an electrical generator.
Yeah, you see
To
the
what
generator down here? Yeah. Okay, and what does it say? What was the next question?
to what form of energy does it change?
Okay, so there's a mechanical, kinetic, and what does it change to? The blue?
Electrical.
Electrical. So that paddle wheel is turning a generator, so you're going from gravitational potential energy to kinetic energy to electrical energy, and then what happens here? The electrical energy heats up a coil here, and that makes
Thermal.
thermal energy. Okay, that's what we're going to talk about in this current chapter. Okay, what's the next question?
I think we answered that one. As the energy goes through the heating coil, to what form of energy does it change? And we said thermal.
Thermal, yes, exactly.
As more of these energy units enter the water, what does the thermometer do?
Yeah, you see that? Here's the thermometer. It's rising. You're absolutely right. The temperature, as we're talking about now, is the average kinetic energy of the water molecules, and you're adding more energy to it so that the thermometer is increasing. I'm getting a little, my hand's getting tired doing this. Okay. Have we answered all the questions there?
No, we have two more.
Okay, what are they?
After the faucet is turned off, no more energy is coming in. What happens to the energy unit in the water?
What it seems to be happening? Every now and then it goes into the surrounding air as thermal energy. And what's happening over here to the thermometer?
It's going down.
It's going down. Was that the next question?
That is correct.
All right, good deal. Okay.
Hello?
Yeah.
I'm sorry. What
What's
happens to the energy units in the water?
okay, every now and then you'll see one of these escapes into the atmosphere. There goes one right there. Okay. So the energy heat energy in the water now heats up the air around it. And as the heat energy leaves the water, the temperature drops because the average kinetic energy of the water is now decreasing again. There goes another one. All right. What's the next question? Was there a next question?
Excuse me. We go to question number two.
Okay, and what's it?
Change the beaker of water to the incandescent light bulb. As the
Okay.
energy from the, I'm sorry.
All right. There we go. There we have a light bulb.
As
Okay.
the energy from the generator goes into the filament of the bulb, to what kind of energy does it change?
Okay. So we're going to start pumping water again. Okay. So you have potential energy becoming kinetic energy becoming electrical energy, As it enters the light bulb, what does it do?
Turns into thermal,
Okay, thermal, and then what?
and it goes into light.
It goes into light, and that's what an incandescent bulb does. Some of it goes to light, some of it, I'll keep pumping. Not all of it goes to light, because notice what happens. It's gravitational potential to kinetic, kinetic to electrical, electrical to heat, heat to light, but not only to light. That one goes to light, that one goes to light. Well, they're mostly going to light now. But every now and then there's a heat, because you know those incandescent light bulbs heat up really hot. So not all of them go to light energy, some of them go to thermal energy. Okay. Was there anything else on that one?
What kinds of energy does the bulb emit?
Yeah, and that's what I was just answering. What kind of energy does the bulb emit? It takes in electrical energy. It becomes red thermal energy. And what does it give off? Light and heat. See, there was a yellow, there was a yellow, there was a yellow, yellow. It's making me do a lot of work for these yellows. Goodness gracious, my finger's getting tired.
And then the next question is,
See, there's a red. Okay. And what's next?
which of these is greater?
Which seems to be greater?
The light,
The light seems like it is. In reality, I think really it gives off more heat than it does light, but according to this, it gives off more light. Okay, so answer that way.
okay.
What's next?
Change the incandescent light bulb to a compact fluorescent bulb.
Okay,
What kind of energy does the bulb emit?
okay. So let's start pumping again. And the potential energy of the water goes to kinetic energy of the water, turning the generator to electrical energy, and then it goes up into compact fluorescent. And what do you notice?
Light and thermal.
Light and thermal. And in this case, I think it should be more light than thermal. There you see quite a few reds, but if we had started over with the incandescent, it was more red to begin with and then more light. This one is more light and then occasionally a red. Okay, so the compact fluorescent produces more light, less heat, which is good. It still produces some heat for sure, but it produces more light than heat. Okay.
Okay, change the faucet to the bicycle. What kind of energy is stored in the bicyclist?
Okay. What's inside of her?
Chemical.
Chemical. She's eaten her Wheaties, hasn't she? Okay. And let's see, how do we get her going here? I think we do it this way. Okay, her stored chemical becomes mechanical. And what kind of mechanical would that be?
Potential.
Potential. No, no, no. It's moving. Kinetic. Now notice every now and then there's a little bit of a heat go out there too. Okay? And now she's getting very tired. So I'm going to have to feed her. What does feeding do?
Give her chemical energy.
It gives her chemical energy. So I'm not going to make her paddle as fast this time. But she's still got, whoops, I guess I have to be pedaling some, that mechanical, which is kinetic here. It turns the wheel, but I can't move my cursor. Okay, she's getting tired again. And that turns the wheel on the generator, making electrical and were we still supposed to be with the complex fluorescent, or did it say?
It did not say.
Okay, so where are we on the questions now?
To what kind of energy does some of it changes as it goes into the surroundings?
Yeah, what kind was that? I'm going to have to feed her again. She's hungry. Okay, there she's happy again. Okay. And as she turns, I'm letting her go real slowly now. There's her chemical going to mechanical. That's turning the generator. Okay, I'm going to speed her up just a tad maybe. But you always have some that becomes, especially the faster you go. Ah, there it won. What did that become?
A light.
Yeah, no, that was thermal. Now the light over here,
Oh, I missed
yeah,
that one. I must have looked down at the time.
okay. Let's see if we can get her again. Ah, there it goes. You see that one? The red one? Did you see that go up?
I missed it.
Missed it again. Okay. Let's watch for them.
I have a question
Well,
about the
there's
light.
one. There's one. You see the red?
No, I missed that one.
Oh,
There we go. I caught it that time. Caught it that time.
okay. But that's from the light. Yeah, we know there's heat produced here. I got to feed her again. And you'll see her chemical goes to mechanical, which is kinetic. And there goes one. You see it right there?
Mm-hmm.
Yeah, that's thermal. Okay. What was your question? There was a question earlier.
Okay, number three says change the faucet to the bicycle. What kind of energy is stored in the bicyclist?
Right.
That is kinetic.
No, look at this. It's green.
That's
That's the chemical energy. That's why when she gets tired, you need to feed her.
green.
See, that's the food that she eats. Chemical, that's what you're burning. That's why you have a temperature 98.6. It's not 98.6 in your room. I hope not anyway, but that's why you are storing, you eat your food, you break down the carbohydrates, you break down the hydrocarbons, and that's what gives you the energy. So that's chemical energy. When you feed her, then she gets this green chemical energy here that enables her to then turn the bicycle wheel, giving kinetic energy. That uh, chemical stored chemical energy becomes kinetic energy as she turns the paddle wheel. Some of it is wasted to heat, like that one did, but others turns the generator. That changes to electrical energy, the blue over here, and then that produces either thermal energy, or light energy. The thermal is red, the light is yellow. Okay. Was there another question in there?
No, sir.
Is that the end of the lab?
No, sir.
Okay, what's the next?
The rest remains at what kind of mechanical energy at the generator wheel, and you said that was light.
Okay, let me go back and read that because I'm okay. All right. So we did the blue pull on the faucet repeatedly. We answered all that one, right? Okay, change the beaker of water to incandescent light bulb. We did that one.
Yes.
Then we changed the faucet to the bicycle, and we did that one.
Yes.
Did we get all that done?
No.
Okay, where are we?
Right there, right. Go up one more with your cursor, right here.
Right.
The rest remains is what kind of mechanical energy at the generator wheel.
Okay, let me start over here. Change the faucet to the bicycle. What kind of energy is stored in the bicyclist? And that was
Chemical.
chemical energy, the green chemical energy. Move the blue vertical bar under the bicycle to the middle of the range. I was moving all over the place. To what kind of mechanical energy does her stored chemical energy change in the pedal?
Kinetic.
That was kinetic. You're absolutely right. Now, you see there's several different kinds of potential energy. chemical is potential energy, but also gravitational potential. We're not really dealing with any gravitational now. All our stored potential energy was the chemical energy. Okay. Now, to what kind of energy does some of it change as it goes into the surroundings? Now, that's the one that you were pointing to, and you said you missed it a few times, but I kept pointing up there and you saw them. Let's go.
Mechanical and some thermal.
Yes. Okay. The mechanical is what turns the wheel. The thermal was that escaped into the atmosphere, the red thermal. Okay, so that was what they're looking for here. The rest, okay. To what energy does some of it change as it goes into the surroundings? That was the thermal. The rest remains as what kind of mechanical energy at the generator wheel. And since it was moving, that what kind of mechanical?
Kinetic.
Kinetic, perfect. Okay. As that energy goes through the heating coil, what form of energy does it change? You want to go back and watch that?
Yes.
Okay. Now let's see. All right. Wanted to see if I still had the right. Here we go. Okay. Need to feed her again. She's hungry. Oh, there she feels better. Okay. Now there's the chemical becoming mechanical, going up, turning the wheel. That's there. Some of it goes to heat. Okay, it becomes electrical, and then the electrical either becomes light or it becomes every now and then there's more light, more light, more light, up a little bit of heat. Thermal is going up there too. Okay, did that answer the questions that we had? I have to go
That
back.
answered those two questions. Um, to what kind of energy does it change by the generator is electrical, and as this energy goes through the heating coil, to what form of energy does it change?
Okay,
Light and some thermal.
right. Okay, now we may have gotten off here. Um, we
Yes, sir.
what's that?
I'm, yes, I'm confused now.
Okay, let's go back to
I'm
this.
about to be confused if my child come in this room one more time.
Okay. I,
Girl, mine too. I have had to put him out twice. I'm like, girl, concentrate.
okay. All right. I think this was the one that we're supposed to be on. We're supposed to go back to the beaker. I don't think we're supposed to have the light bulb anymore. So let's try it again. Doesn't that seem like it makes more sense?
I don't know because it doesn't say that. So
I know, but what does the question ask for? The one that we were stuck on.
is it the as more of these energy units enter the water?
Enter the water. You see, the energy units are entering the water here.
Okay. What does a thermometer do?
Yeah, and what is it doing?
It increases.
Yep, there it goes, slowly going up. So here we have chemical energy going to mechanical energy. A little bit is lost to thermal. The mechanical energy then becomes electrical energy as it turns to a generator. As it goes into the heating coil, it heats the water, becoming thermal energy, and that raises the temperature of the water. Okay. See, I thought we were supposed to change back to something else. I must not have put that in the directions. So let's see if we've got them all answered yet. All right. To what kind of energy does it change by the generator? That's electrical. As that energy goes through the heating coil, that's what was throwing me off. The heating coil, we were supposed to go back to the heating coil. To what form of energy does it change? That was thermal. As more of this energy enters the water, what does the thermometer do? It rises. When the bicycle stops pedaling, what happens to the energy units in the water? Did we answer that one?
No.
Okay, let's go back and do that. Okay. All right, I need the feeder. Okay. There, she's happy again. Okay, she starts converting to store chemical energy into mechanical energy, turning that, a little of it's wasted as thermal energy, but then it turns the generator wheel, which becomes electrical energy, which goes into the heating coil and changes into thermal energy again, raising the temperature of the water. She keeps pedaling. I'm going to speed her up a little bit so we can get this over. Well, she's slowing down some now. Let me
It
speed.
says when she stops pedaling, what
Right,
happens to the energy unit in the water?
in the water. Okay, she's about ready. Oh boy, there she quit pedaling. So what happens to the energy units in the water? They continue to escape into the surrounding, but since there's no new ones coming in here, that means the fewer get here, less steam is produced. There they are escaping a little bit at a time, and the temperature starts dropping. Very slowly, but it does drop. Does that make sense? There goes another one, and the temperature drops. Okay. They still are moving around a little bit, but much less. Oh, there goes another one. Every now and then one will escape. And when it does, the temperature drops a little bit. They're always moving a little bit. Remember, the always is some motion. And there goes another one. Okay. And the energy, the thermometer probably dropped just a fraction of a hair.
And the last question says, increase the pedal speed. What changes do you know?
Okay, let's increase our pedal speed now. We're going to really get her moving. Okay, there's more kinetic energy, probably a little more here, and more electrical energy, and boy, that temperature rises quickly. Starts boiling much sooner, and lots of it starts escaping. Does that make sense? And she runs out of gas quickly. Okay, literally runs out of thermal chemical energy. Did that answer what you needed answering?
Okay, I need to go back to question one,
Okay,
um, where it says, after the faucet is turned off, no more energy is coming in.
right there.
What happens to the energy units in the water?
Okay, let's go back to our share. Okay, we're going back to the faucet. Whoa, there she went. And we got the water there. So let's start pumping water. Okay, and at some point it says stop this. Is that right? Read the
No,
question.
okay, after the faucet is turned off, no more energy is coming in. What happens to the energy units in the water? So
Okay,
after the faucet is turned off, what
right.
happens to the energy units in the water?
Okay, they they keep escaping, but at a slower rate. And so it does start. You see this less steam coming out, and every now and then there'll go one that'll escape, but it's not nearly as rapid as it was a while ago. And the temperature decreases slowly, but it does decrease. There goes another one. So they still escape into the atmosphere. Is this one of my students trying to call me? Good afternoon, Charles Fowler speaking. I don't know. I didn't see, couldn't hear anyone on it. I was afraid one of the students were trying to get to me. Okay, did that answer your question or you need to see it again?
Yes, sir, it answered my question.
Good deal. Okay. How are we doing then?
I had one more.
Okay.
Okay, on number three,
Okay, hold on.
it, sa-
Let me get that back up. Okay, number 3.
Yes, sir. It
Okay.
says the rest remains at what kind of mechanical energy at the generator wheel?
Okay. Let's read what it's talking about the rest. To what kind of energy does some of it change as it goes into its surroundings? Did you get that one? That
Yes,
goes
sir.
in the thermal. The rest remains as what kind of mechanical energy? Now remember, mechanical energy is one of two types.
Kinetic or potential.
Exactly. So which one do you think that would be?
Um, is it kinetic?
Yes, because it's turning the wheel. That's energy of motion. So that would be kinetic. Absolutely.
Thank you.
All right. Any others? Now, is this enough questions, or is there a third page? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yes, I think that's it. All right. I think we got enough questions there. How was that one for you?
Intense. I enjoyed it.
All right. It was trying to demonstrate exactly what we're doing right at the end of the chapter, which was energy forms. That's what it says, and changes. Uh, Potential to kinetic to electrical to heat to whatever, and then stored chemical to it basically showed a lot of the different kinds. The the bulbs I thought did a poor job. The incandescent should have been producing a lot more heat and a little bit of light, whereas the complex fluorescent should have been producing a lot of light with much less heat. I didn't think they did a good job on those, but we got it down pretty well, I think. Okay. If they had shown LED lights, then very much light, very little energy. I mean, very little thermal energy, because wow, those LEDs are very, very efficient. And what's more, they last a long, long time. So it's pretty good stuff there. All right. Any other questions? All right. Anything else on the lab or on the chapter? Now, I'll probably go down and eat supper first, but then I'll come back up and load your. Okay. Are there any other questions on the lab? I can check and see if I've already loaded the test. Do you want me to check that?
Yes, sir.
Okay. I know it wasn't on the weekly thing. Let me see if I don't see. Okay, I'm going to have to go back to. Okay. This is such a pain in the neck. Okay, there we go. Now, let's go to new share, document, Google Chrome. Okay, there is the lab we did today, lab 6. There's the one we'll do on Thursday, lab 7. Okay, what I want to do now is to get out of this and let me move this down, move this up, and let's see if I put it out here on Blackboard Messages. There's Valerie, Amia, and I'm going to have to move y'all out of the way a little bit here. Okay, let's see if I put Angelita. There's the chapter 2 test. I don't believe I've got chapter 3 out here yet. Okay, so I'll put it here under messages. Okay, I'll try to answer some of yours also, but it depends on how much time I still have tonight, because I'm running out of energy fast, and I'm kind of interested in how the election's going. I don't know if it's on there yet. I'm not going to stay up very late watching though. Um, okay, so I don't have it there yet. I'll put it under. Let's go back to. Um,
You gonna put that under week 3 or
no, okay, that's what I was just going to say. I don't think it's going to show up under week 4 because we're in week 4 now. I have a place there for test 3, but I couldn't load it there. It'll be under the messages, that envelope thing. See, I have a thing there for test 3, but when I click on that, see, whoever made up this template didn't put a plus sign here, so I cannot put it here. But you can send it. You can, when you finish the test, you can put it here, submit it here if you want to, or you can send it back to me by Blackboard message, by email attachment, however you want to send it to me. But no, where I'm going to send it to you is okay, go back up to, there's the message. I'm going to move y'all down just a little bit. Okay, there's the Blackboard messages. And you see that's where I put the first 2 labs, I mean the first 2 tests also. There was test 2 right there, and test 1 is right there. Okay, and I could not post it in week 1 test because whoever set up the thing didn't have it set up there. And then this one, I don't know if it's the same thing. Usually if they mess it up in one place, they mess it up every place. So it'll be here under Blackboard messages. All right. And I'll hope to do it tonight. I have it ready. I just didn't want to load it until we finish the chapter. So, any other questions, issues, concerns? Did you think the lab was worth it?
yeah, I enjoyed that.
All right, good deal. Okay. Anything else you want to hang around for, or are we through for this evening?
We're done.
We're
I'm
done?
not watching the election.
Okay. I'm going to try to find a way to get out of here. First, I'm going to stop sharing. I'm sick and tired of sharing here. Okay. If I can get it to stop sharing. There we go. All right. Glad y'all hung in toward the end. I assume all those chats were among yourselves when I lost power and stuff, or lost whatever lost. Okay. Does anything there that I need to see under
No,
chats?
sir.
Okay, good deal. All right, well, then I'm going to end the meeting for all. Y'all take care. Enjoy the returns, I hope, and we'll see you on Thursday. Okay?
Okay.
Take care.
Bye bye.
Bye bye.